This is the last lesson in the learning how to factor sort of series. I am going to do a follow-up showing how to solve by factoring and maybe another on just general factoring methods, right, to show an overview of those factoring methods. But this is the last type of factoring that we're going to learn. And so if you need to go back, if you haven't already watched the other videos, you should go back and watch the video that had group GCF, grouping, star method, difference of squares. We've done all those. If you have two terms and it hasn't fallen into one of those categories, you're hoping that it falls into cubes. That's what this lesson is going to focus on, is factoring things that are cubes. Now, with difference of squares, it had to be a minus sign. It had to be a squared minus b squared. With cubes, it does not have to be a minus sign. It could be a plus or a minus. It could be sum of cubes or a difference of cubes. What we do need, though, is perfect cubes in both spots. We need perfect cubes all around. And I have a list of those perfect cubes for you. Here are perfect cube numbers and perfect cube variables. We're looking for things that look like this left column. If you have those types of things in the left column, then you're in good shape to try factoring using cubes. There is a mnemonic device that I use to do cubes. Some people do it a little bit differently, but you're going to start the same way that you did with difference of squares, is you're going to take these two items and break them into their cubed pieces, their cube rooted pieces, right? So a to the third, if you take the cube root of that, you get an a. B to the third, if you take the cube root of that, you get a b. All right, the second part of it, though, this other parentheses here, comes from the mnemonic SOPPS, S-O-P-P-S, stands for square, opposite sign, product, plus square. Square is exactly what it sounds like. We've got the first item squared. Opposite sign is the opposite of what we had in the problem. So if that was a plus, it's going to turn into a minus. Product is a multiplication. A product is a multiplication. So we take these two items and multiply them to get the product. Plus is always a plus sign. So that's going to be what we're going to fill in first. Actually, that's the easiest thing to fill in. And then square the second one. So if I square b, I get b squared. We'll look at some examples to sort of clarify these things for you. So if I had w to the third w to the third plus 64, looking through the chart, I'm going to say, can I do a GCF? No, I can't. How many terms are there? There are 2 terms. So I'm looking for a difference of squares, or I'm looking for cubes. This is not a difference, and they're not squares. So it's not a difference of squares. I'm thinking that this is going to be cubes. That is w times w times w, and that is 4 times 4 times 4. So they are both perfect cubes. So the way I'm going to start is exactly the way we started difference of squares. I'm going to start with exactly the same sign as my problem had as well. All right, from there, I need my SOPPS factor, S-O-P-P-S. I hope you wrote down that acronym on the prior page. SOPPS stands for square, opposite sign, product, plus square. And so I'm going to fill in the easiest stuff first. This is always going to be a plus, and this right here is always going to be the opposite of the sign that we're given in the problem, so that needs to be a minus. Now, starting from left to right, the first item square is w squared. Product means I need to multiply these two items. 4 times w is 4w. And the second s square means I need to square the second item. What's 4 squared? It's 16. And so this is my factored polynomial. That is factored. Now, I said in the last video that what you want to do when you take any step is you want to try to factor further. What's going to happen, this SOPPS term looks like you could do star method, but star method is never going to work with that SOPPS term. I can tell you now that star method is just never going to work. That is not going to be factorable. This item right here is going to be prime every time, prime. You will get solutions from it when we get ready to solve polynomials, but as far as factoring it, it is a prime polynomial. Let's see another. P to the third plus 125. So I know that p to the third is p times p times p. I know that 125 is 5 times 5 times 5. And so I'm going to start by saying p plus 5. Again, keeping the same sign that I had here. Next, I'll have my SOPPS factor, S-O-P-P-S. Start with the easy stuff, plus opposite sign. If I square the first one, if I multiply, product is multiply, p times 5. And then if I square the second one, 5 squared is 25. This is my factored polynomial. That is my answer there. All right, here's a couple more. I'll do the top one and I'll let you try the bottom one. 27p cubed minus 1000q cubed, q to the third power. So I need to keep everything exactly in the place that it is. As I come down, 3 times 3 times 3 is 27. P times p times p is p to the third. Keep my minus sign. 10 times 10 times 10 is 1000. And q times itself 3 times is q to the third. And now I need to do SOPPS. Always start with a plus. Start with the opposite of the sign that's given to you in the problem. And now square the first item. Squaring this right here, squaring 3p, gives me 9p squared. Product of those two items, 10q times 3p, gives me 30pq. And square this item, squaring 10q, gives me 100q squared. Everything got sort of bunched up there, but that is my solution. Pause the video and try the next one. I'm going to show you my answer in 3, 2, 1. This is what my answer looks like. 2y minus 3z, because 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Then these are my S, O, P, P, S pieces. This should be your solution. That should be your factors. All right, last slide. Factor completely. Again, this is another one for you to try. 27y to the third plus 1. I'm going to give you the hint that 3 times 3 times 3 is 27. 1 times 1 times 1 is 1. And y times y times y is y to the third. And I'll show you my answer in 3, 2, 1. That's what my solution looks like, with this being my SOPPS. And notice I made a mistake here. This opposite sign should be a minus. All right, that is the last type of factoring that we're going to learn about. In a future video, I may do just an overview of all the different types of factoring, and we will do a lesson on solving equations using factoring.